Welcome back. This is an Aleks training video on writing a base protonation constant expression. A base protonation constant expression is the case of B. We did a case of A before where we just basically said what's the constant for the acid. This is a base. So a base is always going to work the same way. You're going to put it with water. Okay, so they've already told you that this is the base. Okay, this is the dimethylamine C5H13N. It's a weak base. You put it in with water just like you would put an acid in with water. The difference is that in acid, the water is receiving the hydrogen from the acid. In the case of a weak base, the water is donating a hydrogen. The water is becoming an acid, and the water is donating a hydrogen to the base. So you're going to look and you're going to have, instead of 13 H's, you're going to have 14. Here's 13 plus one more. And if this is neutral, this is going to be positive because remember, a hydrogen proton is positive. So it's going to go off and then it leaves an OH. Right, so that is what you're going to have to do. You're going to have to be able to come up with the balanced equation. Now this is balanced. It's a 1-to-1-to-1-to-1 relationship, but it's balanced. And once you have that, the case of B is simple. Your case of B, okay, which is your base protonation constant, your case of B is going to be a fraction where you're going to go to the right side and put the concentrations, which is the molarities, of everything you see on the right. So I'm going to write this here, C5H13NH plus, raised to the power of the coefficient. So here's a coefficient of 1, so this will be raised to the power of 1, so I don't have to do anything. Then the next one that you find on the right is the hydroxide, OH minus. It's also raised to the coefficient, so I have a coefficient of 1, so it's going to be raised to the 1. Then I come over to the left, and I ignore the water, because you're going to ignore everything that's solid and liquid. Okay, you're only interested in gases and aqueous. This constant stuff only works for things that can change its concentration. A liquid can't change its concentration. A solid can't change its concentration. So we just ignore them. Okay, so that means the only thing on the bottom is then the molarity of the dimethylamine C5H13N, and that's it. That's all it is. The expression is just used then later to say, is all of this going to break apart? Is it going to be a strong base, or is only a little bit going to break apart? Is it a weak base? Okay, so when you test all these concentrations, if the two numbers at the top, the product of these two numbers is big, and the product and this concentration is low, then you're going to have a huge base constant, which means that it's going to be strong base. It's all going to dissociate into hydroxides. Well, but if it's not, if this number is big and these guys are small, then your constant is going to be little, and it's saying that this is a weak base and that you're going to have mostly mostly reactant and very little product made. So the case of A is telling you that for acids, case of B is telling it for bases. It's the same idea. It's just that it's not an acid, it's a base, so it can't be case of A, it's case of B. Easy, easy.